In a previous video, we worked with the second derivative of a function f that we knew it was equal to ex plus 3x. Okay, and we were able to find that f of x has to be of the form ex plus x to the power 3 over 2 plus cx plus d. Okay, and these cd are constants that we said that are like placeholders. Okay, they are constants that are not known to us at the time. Okay, but we can choose them according to whatever we need to do. That's the spirit for initial value problems. So in an initial value problem, you are given in an initial value problem, you are given more information. And you can be more precise. That means that you can choose the constants. Let's say, for example, that you want to find f such that the second derivative is precisely ex plus 3x, the example we just did, but we also want that function to be 1 at 0 and has a derivative that is equal to -1 at 0. So we are prescribing the value at 0, and we are also prescribing the slope of the tangent at 0. Okay. All right, so let's do it. We know already that f of x has to be of the form ex plus x to the power 3 over 2 plus cx plus d. Okay, so we can take f of 0 and we get 1 plus 0 plus 0 plus d. Okay, but we know that this must be equal to, because of this condition star, must be equal to 1. So that means 1 equals 1 plus d. So that means d must be 0. Okay, so you see that initial value problem, because you are given a value at an initial point x, okay, that already prescribes one of the constants, but actually the other one too. When we take one derivative, that's ex plus 3 halves x squared plus c, and that then we take f prime of 0, which is 1 plus 0 plus c, and that we want it to be -1 by condition star 2. Okay, so that means -1 equals 1 plus c. That means c equals -2. Okay, and with this information, we can go to the general form. So we have ex plus x to the power 3 over 2 plus cx, but c we know it's -2x, plus d, which is 0, so we don't write it. And this is the requested function. Okay, this function satisfies all three properties that we were asked. And then notice that there are no more, there are no longer any placeholders C or D or anything like that, okay? That's because we had more information. Another example would be to find f of x such that the derivative is 1 over x and f of 1 equals 3. Okay, so the first thing we need to do is to find the antiderivative. Okay, so it's the antiderivative of 1 over x that we know it's the logarithm of absolute value of x plus c. Okay, and then we want to prescribe the value of 3 for f of 1, so that this is condition 2. And then we just found it has to be of the form logarithm of x, so that's logarithm of 1 plus c, but this logarithm of 1 is 0, so c must be equal to 3. And the function that we get is f of x equals logarithm of x plus 3. Okay, so I leave a challenge for you. What if f of negative 1 equals 2? In this case, 2 must be equal to f of negative 1, which we know is the logarithm of absolute value of negative 1 plus c. Here the absolute value is crucial, otherwise we would not be able to do this. So this is the logarithm of 1 plus c, so c equals 2. And we get f of x equals the logarithm of absolute value of x plus 2.